In this video, we're going to briefly review the practice final problems. There's 6 problems altogether, and we're going to quickly go through those ideas for each problem. Maybe first one I'm going to do is number 2. So it is substitution about double integrals given here. So the substitution rule is given. So the idea is we want to use Jacobian, but one thing I want to mention, which I didn't emphasize during the video lecture, was that we need to put the magnitude of Jacobian. So let's first recall the substitution for double integrals. So if you have double integral, right, and f dA, we can usually write this dy dx or dx dy. It's fine. But if you're given a function x equals function of u, right, and y equals y of u, then we can have this as after transformed into UV plane. So you need to take du dv or dv du, but in front of du dv you need to put j, which is Jacobian, but this bar means magnitude or absolute value, magnitude or absolute value, because the j is given and then f, whatever f you need to do the substitution, but j is Jacobian, which is defined by the determinant of, in this case, partial derivative with respect to u and v for yu, yv. So this is a determinant of 2 by 2 matrix, and it could be positive or could be negative. So by absolute value we want to put it when you multiply to du dv, you want to put positive value. So it's absolute value. So we can look at this problem here. So let's first look at number B. So inside this is Jacobian notation. So this is absolute. Maybe we can first compute Jacobian. So the Jacobian is xu. We should focus on this. X partial derivative with respect to u is 5, right? Xv is 1 and yu, yv. So if we calculate, this is negative 10 minus 1 times 1, negative 11, which is j, but its magnitude is not negative 11, it's 11. Now number A is sketch the image R in xy plane and UV plane respectively. So in xy plane, 3 points are forms a triangle, so we don't have to be very precise. So we can just do xy plane as usual. And we have 0, 0, and 10 to 10, maybe 2 here. And 2, negative 4, maybe somewhere here. So if we link these 3 points, we have xy plane region, which is R. But after transformed using this transform, right? This transform, then you should have UV plane. So we should have some UV plane triangle. Because this is linear, it doesn't change. A straight line stays straight line, although it will stretch or squeeze them. So they have different angle, but it stays this triangle shape. But what kind of triangle is that? So basically, we want to solve for this problem. You need to solve for u and v from this thing. So from first one, we find we can solve for v in terms of x and 5 values. So we just do the simple calculation and substitute v to the second equation, which is y equals u minus 2v. Then this is u minus 2x plus 10u, which is 11u. And then, so u is 2 over 11x plus 1 over 11y. So you need to solve for u and then solve for v. I'm coming back here, so because I have u already, so 11 10x, so this u is changing by this box, and minus 11 5y, which gives me v equals 1 over 11x 11 over 5y. And then we look at 3, so this is 2 negative 4 and 0 0, 3 points. So x, y, and uv, right? So 0 0, if you put 0 0 in u formula, then this is 0, and of course here v stays 0. And if you put tan 2, so here this is 10, this is 2, put them together, this is 2, u is 2. And you can do the calculation by yourself. So 2 negative 4, it should be 0. So this is basically 2 0 0 2 and 0 0. And the formula you're looking for is, so it doesn't matter which way you go. I go in vertical way, so which means fix u and I look at dv first. Then v is starting from 0 to this one is this one is on the line of u plus v equals 2, right? So v is 2 minus u, and for inside you need to put f, whatever f it's given. By the way, and du dv, you need to put the Jacobian, which is 11, and from 0. And for u is simply changing from 0 to 2. And then the rest of them is calculation. This is for Jacobian, and this is whatever function is in x and y, but you need to replace it by in terms of u and v. All right, we're going to do the next problem. And the next problem is about triple integral, but it involves with a plane equation going through 3 points. So if we look at the tetrahedron for D, then so this is 0 0, and this is 1 0. This is 2, maybe 2 0, P2, and P3 is somewhere here, 3 0. So P1, P2, P3. So the solid D we are looking for is like this. So in this case, usually we go dz, dy, dx. In other words, first thing you look at is when I fix xy, then look for the change of z. So think of this as xy, and you're going to put a stick here. So you're going to put a stick, and then it's going out. So the vertical stick starts from z minus equals 0 and ending at this point, z plus from this plane equation by determined by P1, P2, P3, right? So the thing I want to, so a shortcut I want to introduce for through this example is that we don't need to do general formula which relies on computation of cross product for plane equation. So for this problem, because P1, whenever you have P1, P2, P3 lying on x, y, z axis, then you have simpler formula. So let P1 is A00, that means in x-axis. P2 is 0B0 and P3 is 00C. Then the plane determined by this equation and these 3 points is x over a plus y over b plus z over c, which is equals 1. This is plane equation. So for back to this problem, because P1 is 1, 0, 0, this is y-intercept is 2, this is 3. So the equation here is, this equation is basically x over 1, y over 2, and z over 3 equals 1. And for z plus, of course, you need to solve for z. So z plus is basically 3 minus 3x minus 2 over 3y. So this is z plus. Okay, so whenever you have a plane which going through a point on x-axis, a point on y-axis, a point on z-axis, then just use this. Just use this one, this formula. And for y, when you fix for next layer, fix x looking at dy, then you should put, just take the shortcut, I mean cross section of xy plane, so which is x, y, and like this. So this is 1, this is 2. Then dy, so you're planting a stick when you are given x, then y is changing from 0 to y plus, it's changing to this equation. This equation is because slope is negative 2. So negative 2x, and y-intercept is here, which is 2. And for x range, this is much easier. So from 0 to 1. So x minus is 0, x plus is 1. So at the end, if you put them together, so x layer is 0, 1, but y layer is from 0 to negative 2x plus 2. Z layer is going to be 0 to 3 minus 3x, 3 minus 3x minus 2 over 3y. And then put whatever the formula, integrand. All right, let's look at next problem. Yeah, so it's a solid D bounded by circular paraboloid, which is like a cap you can think of. This is z equals 9 minus x squared. Then it's a parabola in xz plane. But if you have minus x squared minus y squared, then you can think of 3D parabola, which is called paraboloid, and the xy plane. So it basically gives you something like something like this, but it's not sphere or it's not a ball, it's a paraboloid. And for the volume, you can do either double integral or triple integral. So if you do the double integral, then what you need to do is just do in this base, so you can think of this as tent on the circular domain, and every point in the domain you are going to put a vertical line, and when it goes up, so it's 0 to somewhere, which is z, the upper bound is z. So but inside is basically it's like, so if we look at xy plane, then this means you're looking at levels as 0. So 0 equals 9 minus x squared minus y squared. This is a circle with radius 3, right? So this is radius 3. So that means it's better to use polar coordinate system. So it is r dr d theta, and this is z. Z is 9 minus x squared, which is r squared, right? And theta is rotating from 0 to 2 pi, 360 degree, is a whole circle. And rho is 0 to 3 because this is 9 means 3 squared. So that gives me the formula for A. This is for A. For B, we can use cylindrical coordinate system, because cylindrical coordinate system essentially it is using polar coordinate system in xy plane, and z is another coordinate system. So it's like if you use cylindrical coordinate system, this is r dr d theta and then dz, right? But here you want to write, for the volume you want to write 1, and for d theta we already know this is circular domain and 0, 3, but for z it is 0 to the 10th is ending here, which is 9 minus r squared. So this is the cylindrical coordinate system. If we look at the average value for the c, then what you do is total divided by volume. I assume the volume is calculated in A and B, so volume is not a problem. But the total is just copy this formula, except 1 becomes whatever f is given. So 0, 2 pi, 0, 3, 0, 9 minus r squared, and then square root of x squared plus y squared. This is square root of r squared, which is r, right? And then dz, r dr d theta. But this r can be multiplied to here, so it becomes r squared at the end. All right, so the next problem, ice cream problem. So we're not going to test too much strange, weird geometry. So everything in 2D or 3D image should be not everything we tested, every image we tested in final should be contained in one of those practice finals. All right, number 5 is ice cream cone. So basically this is like this, and 60 degree, pi over 3, and there's a cone bounded by a sphere. So, and for this we use spherical domain, a coordinate. In other words, our formula is rho squared sine phi d rho d theta, but phi is change. So phi is changing from. So you can think of the umbrella gradually going to this angle, so this angle, so this is pi over 3, right? For the phi, and for the rho is, if you shoot a beam here, then this meet the upper bound on the sphere, so 0 to the sphere is radius 1. And then for the theta, you can, if you project this to this xy plane, this is circle, a whole circle, 0 to pi. And then you want to put whatever f given, so that's the formula for computation. Number 6 is straightforward computation. We're going to skip that, and at the end, maybe we are going to post the PDF file for the final solutions, which may be helpful on top of this video. All right, thank you.